Hi, and welcome back to the Implementing and Administering Cisco Solutions, the 200-301 video series course by EC Console. My name is Glenn Singh. In this video, we'll be taking a look at configuring PVST+, which is Per VLAN Spanning Tree Plus, Cisco's proprietary version of Spanning Tree. So let's dive in. To configure spanning tree, we need to be in global config, and we use the command spanning tree VLAN. We specify the VLAN ID, so let's say the VLAN ID is 1. We can say root, and we can say root primary to make this switch the primary root bridge for VLAN 1. If we want to configure a secondary root bridge to be the backup, we can use the command spanning tree VLAN 1 root secondary. When we use the root primary and secondary commands, this will ensure that spanning tree configures this switch. Let's say it's root primary, it will configure the switch with the lowest bridge ID. Therefore, this switch will always become the root bridge for VLAN 1. However, the second method is you can use a priority command here. We can say spanning tree VLAN 1 priority and actually set a value between 0 to 61,440, but those values must be in increments of 4096. So the second method, we can actually hard set the bridge priority value for us. So let's take a look at the snippet. In this snippet, we are on switch C1. On C1, we use the command spanning tree VLAN. The VLAN we want to configure spanning tree for, we use a priority command and we say 4096. Then we can use a show spanning tree command to validate what changes were done and what is the current status of spanning tree. Notice that once we use show spanning tree, we can see the VLAN associated for the spanning tree instance. Remember, there's a spanning tree instance for each VLAN to exist on the switch. The first thing we can notice is that spanning tree is enabled and the protocol is IEEE. Technically, this is PVST+, because as you have learned previously, PVST+ is the default instance or the default version of spanning tree is running on Cisco devices. Additionally, we can see this block of information usually is the root ID information. Each switch on a network will contain the root ID information, simply because the root bridge is a central reference point for a particular VLAN. So in other words, C1 will always point towards the root bridge. And you can see the root bridge ID is 4097. We see the root bridge MAC address is this value. But most importantly, look at this. This sentence says this bridge is the root. So this is our first indication that C1 is the root bridge for VLAN 1. Additionally, we can see the hello timers, maximum age timer, forward delay timer as well. Looking down further, this block of information here represents the information that is configured for C1. So each switch has the root bridge information and also has its own information. Now take a closer look at the bridge ID details. The priority value here says 4097, but if we recall, the priority values are only in increments of 4096. So how is this possible? Well, technically speaking, this value here, 4096, is the actual priority value for the spanning tree instance on C1. And we have the extended system ID, which is 1. The extended system ID is also the VLAN ID. So the bridge ID is actually 4097 plus the device's MAC address, because within a BPDU, the BPDU contains the priority value plus the extended system ID plus the actual MAC address. So therefore, this value in brackets of 4096 is a priority value, while this value outside, which is 4097, is the actual bridge ID value, well, together with the MAC address. Another indication that we can determine that C1 is the root bridge is we can compare C1's MAC address with a MAC address for the root ID. If both of these MAC addresses are the same, this means that C1 is also the root bridge. Furthermore, we can take a look at the status of C1's physical ports. We can see all the ports are in a designated forwarding state. Now, the port status should not be the primary thing we check to determine the root bridge. We should always take a look for this sentence here and also compare the MAC address of the local switch with the MAC address of the root bridge. So now that we have an idea on how to configure and verify spanning tree, let's take a look at actually doing a lab on how to discover the root bridge. To complete this lab, please ensure you visit my GitHub using the URL as shown in the browser. Ensure that you are in the CodeWright CCNA 200-301 folder. Once you're there, simply click on Domain 2 and you can download and open Lab 3. We'll be using Lab 3 throughout the rest of this video. So once you have opened Lab 3, it should look like this. Now, the expected result is that we want C1 to be the root bridge and C2 to be the secondary root bridge. But the most important thing is we need to determine which switch here in this network is the root bridge. So let's take a look at doing some troubleshooting commands and also some network mapping commands to help us identify the root bridge. What we can do is click on C1. Let us just expand this window a little bit. Ensure that you're in the CLI tab. And let us go into privilege mode. So let's type enable. Next, we can type show spanning tree to verify the spanning tree instance and the status of the switch. And if you notice here, there is no sentence indicating that this switch C1 is the root bridge. Furthermore, we can see the MAC address of this local switch C1 does not match the MAC address of the root bridge. They are two completely different devices. Furthermore, check this out. Fast Ethernet 02 is a root port, and if you recall, the root port points towards the root bridge. Now we can use this information here to help us find the root bridge. So remember, the root port on C1 is Fast Ethernet 02. So now we can use the show CDP neighbors command to determine which switch is connected to Fast Ethernet 02. So looking carefully, Fast Ethernet 02, the device that is connected to it is D2. So which means that for C1 to reach a root bridge, the connection must go like this. So now that we know which switch is connected to C1 via the root port, which is of course D2, let us click on D2 and determine whether D2 is the root bridge or D2 is connected to the root bridge. So currently D2 has many interfaces. D2 is not the root bridge because the sentence does not exist here. The MAC address of D2 does not match the MAC address of the root bridge. So this is a clear indication, again, that this is not the root bridge. But take a look at this. Fast Ethernet 03 is also a root port. Now let us determine which switch is connected to the root port of D2. We can do this once more by simply tracing this connection using the show CDP neighbor detail command. Well, not the detail, but the show CDP neighbors command. So we know fast Ethernet 03 is a root port. Now let's find fast Ethernet 03 down here. Well, we see that A3 is connected to the root port. So let's investigate A3 to determine whether A3 is the root bridge or not. And take a clear look at this. It literally says this bridge is the root. So therefore, A3 is the root bridge. The MAC address of the root bridge matches the MAC address of the switch itself. Together, all ports are in a designated forwarding state. Now definitely we do not want an access layer switch to be the root bridge. We want a core switch to be the root bridge, such as C1. So now that you have completed this lab, you have learned how to actually discover the root bridge on an existing network. Now, let us move on and configure C1 to be the root bridge for all the VLANs within the network, which is just VLAN 1, and we'll also configure C2 to be the secondary root bridge. So let us open up the same lab that we were using just a minute ago. And now let us click on C1. Next, we can go into global config. And we can use a command spanning tree VLAN 1 priority, and we'll use a priority of 4096. We'll give the entire network probably about a couple of seconds or a minute to reconverge, because this information has to propagate throughout all the switches, telling all the switches that the new root bridge is now C1. What we can do now, hopefully the network has reconverged, we can do show spanning tree to verify that C1 is now the root bridge. And truly, it has worked. So now C1 is the root bridge. Simply, it says this bridge is the root. Furthermore, the MAC address of C1 matches the MAC address found within the root ID section from the show spanning tree command. Furthermore, all ports are designated ports in a forwarding state. Let's take it one step further. Let us configure C2 to be the secondary root bridge, such that if C1 is not available, C2 will now take the role of becoming the root bridge. So let's configure that. So now we will use the command spanning tree VLAN 1 priority 8192. Which is just simply one increment higher than 4096. And that's it. We have now configured C2 to be the secondary root bridge, such that if C1 is no longer available, C2 will now become primary root bridge. Ensure you save this lab, because in the next video, you'll definitely need it. In this video, you have learned how to use various Cisco commands to find the root bridge. Additionally, you have learned how to configure both a root bridge and a secondary root bridge. In the next video, we'll take a look at understanding and configuring Rapid Spanning Tree Plus. I hope this video has been informative for you, and I hope to see you in the next one.